Hello everyone. Welcome to the lesson on absolute value functions, a flipped lesson. As you watch this video, I encourage you to pause it as many times as you need to and rewind it and take notes on what you see. Before I talk to you about what an absolute value function is, we have to first review on what absolute value is. Remember that absolute value is a number's distance from zero on a number line. So, for example, if we're taking the absolute value of -3, we need to think about how far away is -3 from 0. Well, when you think of distance, always think of distance as a positive measurement. For example, if you're saying that you are standing in front of your house and you're going 3 doors down or 3 houses down, it doesn't matter if you go left or right. It's a distance measurement, implying that it doesn't matter which way you go. So -3, if you were to count how many units it is away from 0, you would say that the absolute value of -3 is 3. But you need to be careful sometimes when the negative is outside of the absolute value bars. Let's say I want the negative absolute value of 4. You treat it like it's a set of parentheses. You follow order of operations. First, you take the absolute value of 4, which is 4, but then you apply the negative to it, and your answer is -4. So if the negative is on the outside, you get a negative value, whereas if it doesn't matter what the sign is on the inside, you're going to get a positive value. So here's a quick diagram of what absolute value really is. Okay? It's a number's distance away from 0. You could see with the green arrow, that's with -3. You could see that it's 3 units away. With 4, it's 4 units away, but then if we take the negative version of that, we get -4. So here's what that leads to. Sometimes a function contains absolute value, meaning that the value of x is being evaluated using the rules of absolute value. To create an absolute value function's graph, it's very simple. Just like with other functions, we can create a table of values to figure out what are the y values that go with each x value. So what you're going to do is create a table of values that has at least 7 x values. The reason why I say 7 is because sometimes if you only do 3 or 5, you don't get an accurate picture of what the graph actually looks like. And then after you create that table, you evaluate each x value one at a time. So what I'm going to do is do a very basic example. We're going to graph y equals the absolute value of x. So let's see what happens when we take the absolute value of x. And I recommend that when you pick your values for x, you center them around 0 somehow. So what I'm going to do in my table is when I create my x values, I'm going to use every value from -3 all the way to 3. So 0 is my center. A quick word of warning. Using 0 as your center will not always be correct. Sometimes the center of the graph will move, which you'll see in a few minutes. So I took care of my table. Now I need to find my y values that correspond. But in order to do that, I need to first evaluate each x value one at a time. So what I do is I substitute those values in to see what the absolute value comes out to. Let's start with -3. So if x is -3, the absolute value of -3 gives me my y value, which is 3. So now we do -2. If I take the absolute value of -2, I get 2. If I take the absolute value of -1, I get 1. And then if I take the absolute value of 0, well, 0 doesn't have a distance from itself, so it's 0. So you could see, up until 0, the y is decreasing by 1. But watch what happens here. Once I start taking the absolute value of the positive numbers, it goes back up. So the absolute value of 1 was 1, the absolute value of 2 is 2, and the absolute value of 3 is 3. So I have my x values and I have their corresponding y values. What I can do now is graph those points. So on my axis, I make sure I label my axes, and now I just plot my points and I connect them. So negative 3, 3 would be right here. Then I have negative 2, 2, negative 1, 1, and 0, 0. But then I have 1, 1, 2, 2, and 3, 3. So you could see there's a pretty clear picture of what's going on. And if I kept going, that V shape would continue. An easy way to remember when you're dealing with an absolute value function is that it will always create a V shape. So what you now do is, using a straight edge, you connect your points, and then you add arrows to the ends that extend the other way. So you can see there's a turning point right there. Okay? So everything descends until you get to 0, and then it goes back up. And that's what happens with an absolute value function. Don't forget arrows on both ends, and then you're done. What you guys are going to see in class is that sometimes those functions move. Sometimes the turning point is not on the point 0, 0. Sometimes the graph looks wider. Sometimes it looks narrower. You will be experimenting with that in class. But what I want you to do now is go on the website and fill out the Google form to rate your understanding of the video. I hope after watching you have a better understanding of what an absolute value function is. Thank you for watching.